Okay, the last lecture dealt with limiting reactants, and I went through some steps that you should follow when you're trying to determine what the limiting reactants are. First off, you obviously need to write and balance the equation. Then you calculate the moles, ideal moles. In other words, what are the moles of reactants and products in the balanced equation? Then you have to take what's given and identify the working amounts for each of the reactants, which in this case, the working amounts were these that were given in the problem, 0.5 moles of zinc and 0.4 moles of HCl. After that, what you have to do is figure out how they compare to the mole ratio, the ideal mole ratio that was set up in the balanced equation. Now, once you've determined that, then you can figure out which is the limiting reactant. In other words, which one is going to be totally used up in the reaction. Well, in the last lecture, we dealt with zinc and hydrochloric acid, and what I want to do today is I want to take it from there. So knowing that we had 0.5 moles of zinc, and that in an ideal situation, we would have twice that amount of hydrochloric acid in order to react all of it, then we decided that HCl was the limiting reactant since there was only 0.4 moles available of the hydrochloric acid, and that would determine how much of every zinc we would use, and of course how much product we would end up with. Okay, so the next question is to determine what excess there is and how much excess there's going to be. So knowing first that our limiting reactant is 4 moles, what we have to do next is determine how much of this, or how much of zinc is going to be used. All right, remember before when I said, okay, well, we have 0.5 moles of zinc, and if we were going to react all of that zinc with hydrochloric acid, we would need twice that amount, or 1 mole. But what we found was that we had only 0.4 moles of HCl, so that's our limiting reactant. And knowing that the amount of HCl we need must be twice the amount of zinc, we now have a new starting point. So we're going to take the limiting reactant, 0.4, well, let's change this for a minute. Okay, so we're going to use 0.4 moles of HCl, and we're trying to figure out how much HCl we're going to use. So we know this is 2, and we're going to set up a ratio. So how much zinc, if it's 1 mole? Okay, there's that ratio. Okay, and now we just cross multiply, and we find out that we will need 0.22 moles. Okay, I'm sorry, what did I do? Yeah, 0.4 moles. Okay, we're going to need half of that based on the amount of zinc that we have. Okay, so if we do the math, we have 0.22 moles is equal to X. So what that tells us is that we are going to need 0.22 moles of zinc. Okay, 0.2 moles of zinc. Okay, 0.2 moles of zinc. I don't know where I got the 0.22, but all right, 0.2 moles Cn. And I got that simply by dividing 0.4 by 2. Okay, cross multiplying and doing that. Okay, so what that does now is that tells us as long as we have 0.2 moles of zinc, we will be able to react all of the 0.4 moles of hydrochloric acid. All right, so that's all we need. But in the original problem, we were told we had 0.5 moles of zinc. So the question is, are we going to have to use it all? And the answer is no. We only need 0.2 moles of zinc. according to this up here, which means that we will have excess of 0.3 moles of zinc. Okay? We'll have excess. All right? Excess. Okay? And since we know the limiting reactant gets all used up, we know that we're only going to use 3 moles, 0.2 moles of zinc, and therefore we will have excess zinc. In other words, some of the zinc won't get used. Okay, so now what we want to do is we want to take that information and we want to rewrite the equation. 0.3 moles, 0.2 moles of zinc will react with 0.4 moles HCl and will produce and in this case we have to go all the way back up to our original equation and figure out the ratio. So it's going to be a 1-to-1 molar ratio. So we're going to produce 0.2 moles zinc chloride and 0.2 moles H2. Okay, so we go back to our original and we say, okay, did we come up with the same ratio, 1 to 2 to 1 to 1, as we had in the original balanced equation? And the answer is yes. We've now done a limiting, we've identified the limiting reactant as well as the reactant that will have excess. Congratulations.